Welcome to qnawire.
Okay, we've got two electrostatic potential maps. One looks like this. Sorry, electronic potential maps, interatomic distance potential maps, and one like this. Okay, and remember, this here is distance between the nuclei, and this is potential energy. Okay, so one is for potassium ions, and one is for fluoride ions. Which is which? So the question really is, okay, this is the minimum in potential, or the minimum, the equilibrium bond length, right? And this is the other equilibrium bond length. So what they're really asking is, if you have potassium bonded with itself or fluorine bonded with itself, which of them would you expect to have the lower internuclear distance at the minimum of the potential energy? Which of them would have the lower equilibrium bond distance, right? So let's take a look at our periodic table. Right, so here's fluorine. It's like one of, other than hydrogen, the smallest element that we have. And then potassium, right, it's, remember, large is in the top left, and small is in the top right. Large is in the bottom left, small is in the top right. As we go down, elements get larger, and as we go to the right, elements get larger. So potassium is quite a bit larger than fluorine. So which of them then should we expect to have the smaller or closer equilibrium bond length? Fluorine, right? So this is clearly for fluorine, and this one is clearly for potassium. Oh, I misunderstood. It's potassium and chloride versus, okay. I thought I was comparing potassium to chlorine. Well, same idea. Right, so we're saying one of them is for potassium chloride and one of them is for potassium fluoride, but we're still, so the potassium's the same in each case. But the point is that chlorine is larger than fluorine, right? So the potassium and fluorine will get closer. This is for the potassium and fluorine, and this one is for the potassium and the chlorine.